So today is October 28th, and I just went to try to post the video, and something apparently happened with the recording, and it did not, you could see it, but you could not understand it. It was nothing but static, pretty much. So it's possible that my speakers no longer work on my old computer that I use in the classroom. So I'm trying on a different computer. So hopefully this comes through, and I'm going to do a shorter version. So the first thing I want you to do is I'm doing exactly what we did in class. Well, actually, that's not where we started though. I want you to do this bell work. So try to reflect over y equals x. Try to reflect over x equals 1. Pause it and do both of those now. So you should be back. Hopefully you were able to do those. If you're not attempting to do them on your own, you're not going to retain this if you just sit there and watch what I do. Told you guys that over and over and over again. Just watching something or even just writing something down is not going to help you retain it. You have to try to do it and then make corrections when you get things wrong and then try to do it again. That's how you learn. That's the process. If you don't struggle with it a little bit, you're not going to retain it. So anyway, if you want to pause it now and try to do it again, if you didn't do it, pause it now. All right, so now hopefully you tried it. So in class, I told the kids, I said, these two situations right here are really the priority situations for you to understand when it comes to graphing the line of reflection. If you can just get these two down, and if you can make sure you absolutely positively 100% know these without even having to think about them, then I think on all the other ones, when you have to think about the other ones, you'll be able to figure those out. And I'll explain why I think that in a second. So I'm hoping that reflecting over the x-axis and reflecting over the y-axis just become second nature. Like you can do that one without thinking about it, mainly because you should know where the x-axis and the y-axis are. If you have to reflect over the x-axis, well, then you just make the x-axis the line of reflection. If you have to reflect over the y-axis, you make the y-axis the line of reflection. Again, you should know where the x-axis and y-axis are. So those should be taken care of. Now, and I'm going to do the one on the right where it says reflect the point over x equals 1, right here. So if we know how to graph this, and I'm not going to spend a bunch of time showing you how and why x equals 1 looks like it looks in a second. I did a whole lesson on this in a different video if you want to go back and look at that. But it goes against your instincts if you remember me saying that, because a lot of kids think, oh, well, if the x-axis is flat, then graphing x equals 1 has to be flat. That is not correct. X equals 1 is a vertical line, straight up and down. The reason is, if you look at that line, every point on that line, and again, a line is just a bunch of individual points that are so close together they look solid. So every point on that red line, x is equal to 1. If I were to write the x and y value, x comma y, the x would always be 1. That's why that's what x equals 1 looks like. So again, make sure. Oh, and by the way, you guys always say how tough the class is. So if you missed this day, I'm going to preach for a second. The class is not tough because of the geometry. The class is tough because we didn't retain a lot of the algebra we're supposed to know. Graphing the line of reflection is algebra. That is not geometry. Understanding what the line of reflection means and then what to do with the point after you graph the line is geometry, but putting that red line on there is algebra. Every line we create for the line of reflection is algebra. This is the geometry part. Just knowing a reflection over that line just means you count to the right twice and you count 2. That's why they give us so much material to cover, is because they expect you to know all of the algebra, and the algebra sometimes is half of the lesson that we do, if not even more. So you're better at your algebra and you're going to be better at your geometry. All right, so now if I 100% know that x equals a number is vertical, if x equaled -3, it would be a line straight up and down through -3. It's always going to be the number on the x-axis. So one of these numbers down here, they're not going to give you a decimal, I wouldn't think. So one of these numbers down here on the x-axis. Now, here's why I think if you absolutely positively never forget, don't even have to think about x equaling a number being a line straight up and down, you're not going to use the same lines twice if you're reflecting it over something that's different. So if I said reflect it over y equals a number, hopefully it would make sense that that can't be a line straight up and down. If x equals a number is straight up and down, y equals a number can't be straight up and down. So pause it, think about what it would have to be. If you don't know, what would make sense? So you should be back. Y equals a number then would be a flat line. It would be a horizontal line. Again, it's kind of the opposite is the way you think about it. When you do x equals a number, that's kind of the opposite looking line of y equals a number. So again, if I said y equals -3, y equals -3 would be a line down here, horizontal, where y is -3. So again, if you just memorized how x equals a number looks, hopefully you can kind of figure out how y equals a number looks. So kind of the same concept over here. You really memorize this, and this, by the way, would be the same exact thing as x equals y. That's the same exact equation. Doesn't matter which side of the equal sign they're on. If that's the same exact thing, both of these equations, these are little equations, y equals x is an equation, x equals y is an equation, are going to have the same line of reflection. Again, I did a whole long lesson on why this is true. I'll mention a couple of things, but think about how that would be if you didn't already do it. Pause the video if you need to, if you didn't do it earlier. That line is going to look like this. It's going to be a line diagonal. So again, if x equals a number is straight up and down, y equals a number is flat, kind of makes sense that y equals x wouldn't be one of those two. I told you before, the reason, kind of the best explanation I could give you on this is these two equations are telling you that the x and the y value have to be equal. That's what x equals y or y equals x means. And if you'll notice, every point on this line, and I'm just going to do a few of them. I don't love that color. Let's go with black. There. I could keep going into the negatives. So there. Every point I just highlighted, or every point on that line I drew, the x and the y are the same. 3, 3, 2, 2, 1, 1, and then down in the negatives, -2, -2. That's why that line looks like that. So again, if you just absolutely positively make sure you don't even have to think about the way that line looks, y equals x or x equals y. Oh, and then the reflection we said is a little tricky. You have to kind of go diagonal. You can't like just go straight right or just straight down. We would say, and I would draw this in when you do my quiz. We said we kind of have to go diagonal. So we go 2 diagonal spaces, and then we go 2 diagonal spaces again. And that's where the point would be, right there. 3, -1. So, and we'll get into the rules more when we do the full lesson down the road. Make sure you draw those lines in. If the graph has smaller squares and more squares and the point's farther away from the line of reflection, when kids try to just visually look and follow the diagonal squares, they mess up a lot of the time. So just draw in diagonals like I just did. I don't care if you write on the paper, and they don't care if you write on the paper if you are doing the EOC, if you have graph paper. If you don't have graph paper, you should be able to request it. Or if you need to somehow on the computer screen or something, try to line it up with the edge of a paper or something. Don't just visually try to follow it. So the other way I showed you is that you could also do this if you wanted. You could go along the grid lines, but you have to go up and down and left and right. Can't just go up and down or just go left and right. Then on the other side, you draw out follow the grid lines again until your two lines meet. And if you'll notice, that's the same exact place we put the green dot before. It'll always be on the opposite corner. Oh, it'll always form a square, as you see there. And your point will always be on the opposite corner of the square. So again, if you know that pink line, that is the way, actually, I'm going to get rid of the actual point we just put. That's the way y equals x looks. And you never, ever even have to think about that. Well, when they give you one where it says y equals negative x, and that's going to be a different line, hopefully you think, okay, well, that's kind of like y equals x. It's not the exact same because of the negative. So now I want you to think, well, what could that look like? Pause it. So now you should be back. Well, I'll tell you right now, it can't look like y equals a number or x equals a number. So it's not going to be straight up and down or straight left and right. It can't be the same diagonal line we just did when we did y equals x. So kind of the only thing left, I'm going to use pen for this, is to draw a line straight through the origin, but now it's going down and to the right instead of up and to the right. So very similar to what we just did. And then the last step would be the same. We would go diagonally 1, diagonally 2, diagonally 1, diagonally 2. And it would be right there. Or we could do the square thing that I just said, go that way, all the way to the line, all the way to the line. And then on the other side, all the way to the line. Just make sure it makes a square when you finish it. All the sides have a length of 4 in this particular square. And our point is on the opposite side, opposite corner. All right, so that was first thing we did. Then we came to this. This is right after the quiz that we did this lesson, if anybody's really listening to it late. And I talked about how the quiz went, which, even though the average wasn't horrible, it was also straight from IXL questions. So I really expected the people to do better. I looked up IXL scores, and a lot of people didn't even practice IXLs outside of what we did in class. So I've told you over and over again, I don't know how you expect to do well in this class without putting work in outside of class. It's not going to happen. So you got to put some time in outside of class. So go ahead, try to do that problem real quick. Pause it because I'm going to just keep going in a second. You're just solving for x, by the way. Oh, really quickly, this is the language that I told you about in class one time. It's kind of weird language. It says find the value of x that makes j parallel to k. This means parallel if you didn't remember. That just means solve for x, assuming that the two lines are parallel, that j and k are parallel. That's all that wording means. So just assume they're parallel and solve for x if you see wording like that. Okay, so you should be back after trying it. If not, pause it now. So again, on the quiz, when we did, there were 2 questions that were on transversals, and a lot of people, unfortunately, a lot of people didn't pass. If you didn't set the correct equation up for one of the problems, you didn't pass, and a lot of people didn't. Some people did set the correct equation up both times, but they forgot to read the question after they solved for x. Because remember, sometimes after you solve for x, you need to plug it back in, and maybe they wanted the measure of that angle right there. So you needed to plug it back in and figure out what the angle was. So just make sure you remember that if you do the retake or if you haven't even taken it. So I'm not a big fan of tricks, but I showed them a trick in class that I'm going to show you here. And we're going to do the trick twice. I want you to understand the definitions of the different types of angles and which angles are congruent, which angles add up to 180. That's going to be something you need when we get to other figures, like maybe triangles. So I'm just going to go ahead and if we have a triangle and then there's a parallel line in the triangle, so if that middle line and that bottom line are parallel, you need to understand which angles are congruent, and the trick I'm about to show you will not work on other images, other types of figures. It will work if you just get this exact figure right here, something like that. That's when it works. And you could do it in some other situations, but it's really just for when you have to solve a problem, exactly like I just circled. So here's the trick. And I already showed you this once, it's not new. If you just can't remember which angles are equal or visually you can't tell, and this works no matter what, if I have a picture that looks like this, where it's kind of more straight up and down, or a picture that looks like this, where the line is slanted the other way, works in all of these situations. I told you, number, but number in a different order than what we've done before. 1, 2, and then put 3 here, and then 4 there. And then you come down here and you start with 5 and you go in that same direction. So this would be 6 right there, 7, and then 8. So those numbers are just, I'm just naming the angles, angle 1, angle 2, angle 3, angle 4. But I'm naming them by going around in a circle instead of dropping down into the left to do 3. I kept going in a circle to do 3. Same thing here, I kept going in a circle. If you memorize and then you do it in all of these, 1, 2, 3, 4. 1, 2, 3, 4. And then I could do 5, 6, 7, 8. They're going around in a circle every time. You'll notice all the numbers are in the same place. Looks a little different, but 1 and 2 on top, then 4 and 3, then 5 and 6, then 8 and 7 every single time. So here's how you use that. I'll just put it over here. The even angles are all equal to each other. And you kind of should know that because if I look and I think about vertical angles, those are vertical angles. So 2 has to be congruent to 4. And sure enough, they're both even. 8 and 6 are vertical angles. They have to be even because they're vertical angles. Well, I also know, if you know your definitions, 4 is congruent to 8. 2 is congruent to 6. And they're all even. So even angles are all equal to each other. Same concept is true for, actually, I'm going to get rid of the yellow. Same concept is true for the odds. 1 and 3 and 5 and 7 are vertical, so they have to be equal to each other. Well, again, if you remember your definitions, 1 and 5 are corresponding angles. They have to be congruent. 3 and 7 are corresponding. They're congruent. 3 and 5 are alternate interior, so they have to be congruent. 1 and 7 are alternate exterior. So again, all of the odd angles are equal to each other. And then the last thing is, I'll just do it this way. Let's see, we'll use an odd and an even are not equal. They add together to equal 180. And again, it makes sense because if I do this right there, that's an odd and an even. And we know those have to add up to 180 because they're part of a line. They're linear pair. We could also do that down here. Here's an odd and an even down here, 5 and 8. Well, again, that's a linear pair. They have to add up to 180. Well, that's true for every odd and even. You could pick any odd and even angles in this picture, and those two angles would have to add together to equal 180. So with that in mind, I can kind of figure out, well, okay, well, in this particular problem, what are the numbers of the angles that I have? So I want you to try to figure that out. It has nothing to do with the 3x plus 10 and the 5x subtract 10. It has to do with the green numbers that I put in there. So you should have figured it out. We are dealing with angles 4. So 4 is this right here. And 6. Oh, I kind of missed it, but you get the point. Angle 6. Well, now I just say, okay, well, are they both even? Well, in this case, yeah, they are. So if they are both even, then they are equal. Well, now I just plug in the equation, or it's not really called an equation. So I just say, okay, well, angle 4 is 3x plus 10. So that has to equal 5x subtract 10. Now you have to know how to do the algebra. I cannot combine that into 8x. I've done that a million times, I feel like. I can't just add 5x to 3x, because if I did, I would have to add it on this side. Whatever you do on one side, you got to do on the other side, remember? That's the most important rule. Well, that doesn't help me any if I do that. So that is not the correct first step. We cannot combine them into 8x. I need to subtract 3x on that side to get rid of it. Well, if I subtract it on that side, I have to subtract it on that side. So you get 2x subtract 10 equals 10. Now you should definitely know how to do it. Add 10, add 10. So 20 equals 2x. Divide by 10, divide by 10. So x equals, I said divide by 10. That was wrong. Divide by 2. Even teachers get in a hurry. Divide by 2, because 2x, I'm getting rid of the 2, so I need to divide by the 2. Jumping ahead because I was trying to get to the answer already. Now, what I do want you to know, so again, you can pause it if you need to pause it and go back if you need to go back, because I'm going to get rid of all of that. If x is 10, which is what we just got, and you plug it back in, you get that this angle here measures 40 degrees. 3 times 10 is 30 plus 10 is 40. That means all of these skinny angles would be 40 degrees. Well, hopefully you can look at that and tell, well, wait a minute, that's not right. That does not look like a 40-degree angle. But remember, I told you, don't think things are drawn to scale. They clearly drew this not to scale, just so you couldn't guess at the angle, I guess, or they just made a mistake. I don't know. None of the angles in this particular worksheet, though, were drawn to scale. So I think they just used the same figure over and over, maybe. All right, try to do this one really quickly on your own. And I'm just going to solve it out real quick. Whoops, that didn't work. I don't even remember where I put them in class, but we'll put them there. So again, do that whole process on your own, solve for it. You can then solve for both angles if you want to solve for both angles. Whenever you're done, just come back, but I'm going to just keep going. All right, so the process is, again, if you're not done, pause it right now and work through it. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Well, now I just look at where I have the information. Well, I have angle 2 and angle 5. Well, nope, they're not both even, so I don't set them equal because of that. They're not both odd, so again, I don't set them equal because of that. One is odd and one is even. Well, that means I add them together and set them equal to 180. Yeah, I'll just get rid of all of that. So if you do this, you would say 6x plus 25 plus 10x subtract 21 equals 180. Now, this is the math that we're a little bit better at when the x's are on the same side. 16x, combining the two numbers, 25 subtract 21 would be plus 4. That equals 180. Subtract 4, subtract 4. 176 equals 16x. So you should have gotten all of this. And I'm pretty sure, if I remember, I'm not going to do it in a calculator, but I'm pretty sure that that is 11. And then oh, I don't even know if I mentioned it in the video, but don't forget to check the question. Because in one of the questions, it did say, what is the measure of the angle, not just solve for x. So if I plugged it back in, that would be 6 times 11 is 66. And then 66 plus 25 would be what, 91, I think. And just to make sure, you could plug it into the other one and it better be 89 because they should add up to 180. So that would be 110 subtract 21, which I do believe is 89. So I'm just plugging 11 into X for that little mini equation, that little expression. And you should get 89, I'm pretty sure. All right, so that was the second thing we did in class. And then the last thing we did, I told you a lot about the quiz grades and about your next quiz. Your next quiz is going to have proofs on it. I did not put any proof stuff on the last quiz, so I'm going to move it to the next quiz. It might have more on there now than I was going to originally have since it's moving to sort of its own quiz. But when you practice, and you're going to get some practice time in class if you are watching this before class, that is, the IXLs, and I am going to pull the proofs problem straight from IXL, they repeat the same stuff over and over again. You'll see here, definition of complementary angles is repeated within the same proof. This definition of congruence is repeated. This properties of addition and subtraction, they use those over and over and over again. The one that we're about to answer right here, they also use over and over and over again. So make sure you're paying attention, not just to the one that you're doing in the drop down, but make sure you pay attention to all the other ones. They love using definitions as well. So how can I do this? So if they give you a definition, or oh, do I use maybe this? Oh, why can I not use my finger? That's weird. So if they give you a definition, that's going to be a reason. They're going to say, okay, well, it's because of the complementary angles that they told me about. If they tell you lines are perpendicular, then definition of perpendicular lines is going to be in there. If they tell you something supplementary, definition of supplementary angles is going to be in there. If they tell you there's a midpoint, which isn't really in angles, but definition of midpoint is going to be in there. So when they give you stuff up in the problem itself, I mean, technically this is given information, even though they don't really say given the way the book does, you're going to be using that. And the reason you can put numbers behind it is the definition. The fact that they are complementary is the given, like they say right here. The reason you can then put numbers behind it, that is the definition of complementary angles. So with that in mind, zoom in. So let me get, I don't know how to, shoot. Oh, actually, no, I just have to, this is their tools. This isn't Spark Notebook. There we go. Well, that didn't work. There we go. And just remember also the thing you're trying to prove is always the last statement. You see down here, there's that statement. It'll always be the last statement. All right. So with that in mind, here, yeah, there we go. Perfect. Here's one they use a lot. It's one of the tricky ones, but you got to practice it and get it down because there's a pretty good chance you'll see it in one of the proofs because it's in almost every proof they do. If you see two statements that look let me see. I may not be able to write in. Oh, wait. Actually, I was on eraser, so maybe I can. Two statements that look really similar and so similar that they actually repeat a part of it. One of the sides of the equations is repeated. 90 is on the top one and in the bottom one. That's when you need to think about that A equals B, then and B equals C, then A equals C thing. Ugh. How do I do that? Oh, there we go. That is so weird how the color is changing in this. Huh. I don't know why it's doing that. So the way you test that out, shoot, I've got to go all the way back down to erase. So the way you test that out, it's really tough to tell sometimes by matching up like all of this. I'm just going to use the mouse. By trying to match all of this stuff up and this stuff up with this stuff down here, that can be tricky, I think. If you can do it, then great. But what you could do, man, I'm going to have to do this. I'm just going to leave that line. That's fine. You could say, okay, well, I know that this side, if this were going to be that it's called the transitive property, that would be my A, 90 would be my B, because the first step is A has to equal B. The second step is that B has to equal C. Well, again, B would have to still be the same number, so that would still be B. This then would have to be C. So that's how you would label them. So now the third step, if they're using the transitive property, the third step, so we're down to here now, that would be A equals C. So you just look at what they gave you and say, well, is that A? Is that statement I just underlined A? Well, it sure is. Measure of V plus measure of X. So yeah, that is A. So check that off. That's A. Well, is this statement right here C? Well, sure enough, this statement is C. Measure of V plus the measure of W. So that is C. So therefore, all three of these are the same exact things they're giving me over to the left. A equals B, B equals C, and then they give me A equals C. So that is again called the transitive property. I don't, I'm gonna have to get rid of that, I think, to select. Yeah. Now I'm gonna make it a little easier. I'm not worried about you. Like there's two transitive properties in the IXL proofs. I'm only going to give you one that just says transitive property. This one is the transitive property of equality. The only difference is you see how there are equal signs here. That's why it's the transitive property of equality. If these were congruent signs, then it would be the transitive property of congruence. Typically, that one would be used more with shapes, not with like the measures of angles, but like if you had two triangles that you were trying to prove were congruent, you're typically going to use the transitive property of congruence in shapes. So the last one, oh man, I can do this. There was a faster way to clear this out. Can't do that. Hopefully, did that work? Oh, that did work. All right, didn't even know that. So now the last two, they love this one too, this properties of addition, subtraction. All they did is they subtracted V from both sides. You see how V is here and V is here. So they didn't show you that they did this, but they subtracted V from both sides. So that's why that is properties of addition, subtraction, etc. And then the last one, you better not miss this one if I give you an easy one. This is all that really changed. The equal sign went to a congruent sign. They took away the M, the measure of part, but it's still angle X, angle X, angle W, angle W. The main thing that changed was just the equal sign went to a congruent sign. That's the definition of congruence, which you see right here. They already did it for you. That definition of congruence also applies if we go from a congruent symbol to an equal symbol, which I'm going to do one more proof and we might see that, we might not. I only did one proof in class, but actually one class did get to two. So we'll submit that. I'm going to do this one quickly and then do another one. So the reason that they give you this little guy here, I'm talking about I don't know if I can do this. I was afraid of that. There, we'll do this. That symbol right there, we said means perpendicular. Two lines are perpendicular. If you see that symbol, there's only one thing that it's going to mean. It's going to mean that somewhere in the proof, you're trying to figure out that something equals 90 degrees. Since we're trying to prove this, it'll be at the end. If that was part of the given information, then the fact that an angle equals 90 would be toward the beginning. So it depends on whether or not we're proving it or whether or not it's given. We may do one more after this. So anyway, given information right there, that's just from the picture. They're telling us those two angles are congruent. So it doesn't always specifically have to say given. Sometimes they're just going to put markings in the figure and you have to know that that's given. Let's see. The fact that they kind of already filled all of these in. The fact that this one I could see you mistaking for the transitive property later down here. Actually, let's go over why that's not transitive property. So if I label this right here A, the reason I'm testing it is because this 180 is repeated. That would be B. So again, that would be B again, and this would have to be C if it were the transitive property. But then we have to test this next line. And on the next line, because right here we have A equals B on line 2, here we have B equals C. So this line down here would have to be A equals C. Well, this is not A and this is not C. So that isn't the transitive property in this one. The third line does not represent something like that. So I get that that one's tricky, but like I said, it is all over the place in these IXLs. So if you're not getting it, then you need to just practice enough of these to where you recognize it. All right, so really quickly, angles form a linear pair. That's a big one you got to know. Sometimes, though, it's just going to call it linear pair. The book just calls it linear pair. They don't call it angles forming a linear pair sum to 180. That basically means the two angles are right next to each other on a line, and all we're doing is we're splitting the line into those two angles. So if you notice where those two angles are, it is FJG, which is this one, and then it's GJH. So if I draw a semicircle through both of those, that's linear pair. So it's not supplementary. It's not definition of supplementary. It's not angle addition, like little plus little is big. It is specifically linear pair because, I mean, they almost drew a semicircle for you when they told you those two angles were congruent. But so if you can draw that semicircle, it's this right here in IXL. In the book, it's just called linear pair, definition of linear pair or something like that. All right. So now, again, if this is not transitive property, I got to figure what's going on to get from 2 down to 3. Well, if you'll notice, that just goes straight down. It doesn't change. That just goes straight down. It doesn't change. Only thing that changes is this became that. So if you look right above, and a lot of times this is going to be the case, if only one thing changes, you need to think, well, maybe it's because these two things are the same. Maybe they're equal. They're congruent. They're the same as each other. And sure enough, if you look right there, they are. They're the same exact thing, which means I can replace GJH with FJG, which is exactly what they did. They just replaced GJH with FJG because they're equal. They're the same. They're congruent. Now this is one of those math things. They're doing one of those math definitions. Hold on, let me get rid of, there we go. So they're saying, okay, well, I have FJG plus FJG. That's like 2. Oh, I can't write. That's like 2 times FJG. So I need to divide by 2 to get rid of the 2. Well, if I divide by 2 on this left side, I got to divide by 2 on the right side. That's how they got the 90, and that's why there's only one FJG now. And then the last step is, Well, if the measure of one of those angles is 90 degrees, FJG is 90, the only way that can happen, the only way I can take a straight line and divide it into two angles and have one of the angles be 90 is if the lines are perpendicular. That's the only way to get a 90-degree angle, if I divide a line into two angles. So that's why we get the definition. Oh, actually, it's not here. So it was in the, I think it was in the last. So definition of perpendicular lines. And just look at the other ones. I mean, hopefully, although this one is a little trickier, but I mean, it doesn't really talk about two angles. I mean, I guess it does. This would be a tricky one. It does talk about two angles being congruent, which is kind of an angle bisector. Doesn't really mention two angles adding to 90. It says one angle is 90, so you should be able to understand it's not complementary angles. Angles forming a linear pair. Well, this last step doesn't have to do with 180 degrees. So it's not going to be anything to do with linear pair, not for the last step. And then definition of supplementary. Again, this last step is all we're looking at. There's nothing about angles adding together in the last step. It's just about one angle being 90, and then that meaning that we have to be talking about perpendicular lines. So definition of perpendicular lines would be what in the world would be the answer to that one. So again, this is about perpendicular lines again. One last thing, I'm not going to keep going because we'll do more of this in class. When you see two statements that look, and I don't know if I've already said this, two statements that look pretty much the same, IXL repeats the reasons a lot. So if one of them is definitions of perpendicular line, that's why UVW is 90 degrees. RST is going to be the same thing. I don't think they give you a picture in this one. Yeah, it's going to be the same thing. Like that's why they're 90. The book doesn't do that as much where they repeat the same exact reason, but this IXL lesson does. And then you can see transitive property was used. That would be the A. You'd have to label these A on that side, B on this side. Well, then this is B and this is C. So then I would just check and see if is that A and is that C. Well, there's A, UVW. Yep, UVW. There's C, RST. Yep, there's C. So the final statement is the same as A equals C, just like this was the same as B equals C, and this was the same as A equals B. So this right here is the transitive property. Got to figure that one out. They're using that one a lot. And definition of congruence. Like I said, they use that a lot. So here's what level is this at? Because yeah, level 2 is where I'm going to choose the questions from when you have more than one thing to choose. So I might give you one proof that has 2 drop down boxes and one proof that has 3. So just keep that in mind. We'll practice some of them in class. I'm not going to go through this whole thing. It looks pretty similar to all the other ones. Really, just you have to come up with more than one reason, but the proof itself is pretty similar. So you can try to do that one if you want, come up with what you think it is. I'm not going to go through and do it.